We've got our data now in X train, Y train, X validation, Y validation. But in a previous video, we evaluated our model using the score function. What does the score function use? It uses the coefficient of determination. But if we remember right back up the top, we'll go right back up the top just to check it out because we wrote this down. We know that the evaluation metric for this competition, so for this project that we're working on, is RMSLE, or in other words, root mean squared log error. That's not the same as coefficient of determination. And if you're wondering where we got this evaluation function from, it's from the Kaggle competition overview.evaluation, which we saw right at the start, but we'll just check that out again. Evaluation. So the evaluation metric for this competition is the RMSLE. We can Google that to see what it actually is. So let's go here. Root mean squared log error. What is the difference between? How do you interpret root mean squared log root error? Okay, so we got a fair few options there. So if you wanted to read further, these are something you can look up, but we're going to work through this in code. Let's go down. You might be wondering, we haven't seen or really mentioned root mean squared log error. That's a bit of a mouthful in itself. So what we might do, we're going to have to create our own evaluation function, because if we come back to our keynote, so classification and regression metrics, we're working on a regression problem here. This is one of the slides from, I think it was the sklearn section. We got a mean absolute error, okay. Mean squared error, MSE, okay. Root mean squared error, but this is missing the log component. Let's see if we could get that in through sklearn. So we'll go back here. What we might do is build our own. So building an evaluation function. Now, this is something you may have to do depending on the project you're working on, right? So if we're working on this Kaggle competition and they say that for some reason we have to use this metric, who knows, the people who posted this challenge may require this. They may have decided this is their best evaluation metric. Depending on what project you're working on, you may have to find an evaluation function which suits your use case the best. And so what we're going to do is create evaluation function. Because we're going to be running multiple experiments, we want to be fitting multiple different machine learning models and evaluating them. That's why we're going to build it into a function so we can use this functionality multiple times without having to repeat ourselves, because we're kind of lazy when it comes to writing all this code. You know, I just want to experiment more and more. Create evaluation function. The competition uses root mean squared log error, RMSLE. So we can go from sklearn.metrics. I can tell you scikit-learn, you could go to the sklearn evaluation metrics, but we can go through here. We can have a look at some evaluation metrics. Mean squared log error. Okay, so we might use that. Mean squared log error. But we're gonna have to add our own little piece on it, because this is not root mean squared log error. So what we might do is we might take this one, and we can import that. Let's do that. So from sklearn.metrics, import mean squared log error. And for the hell of it, we'll do mean absolute error. You make predictions on all the examples, and then you minus your predictions from your actual values and take the average. That's the mean absolute error. So how much on average is your prediction from the actual sale price? But mean squared log error is more to do with the ratio. And most oftentimes with regression problems, right? If you're like $10 off something, like so if we were $10 off this sale price prediction, wouldn't really matter. But if we were 10% off, that'd be pretty bad, right? We don't want to be more than 10% off. Whatever value, insert something, it could be 20%, it could be 30%, but that's kind of the difference between these two, right? Anytime you see absolute, think of it as being $10 off, and anytime you see like squared or some sort of log, or think of it like the ratio, so being like 10% off. That's when these two, you can really compare them to each other. But we've got a little bit more of that in the slide. You might want to take a screenshot of that. That is a pretty good one, but this will all be in the slides you can check out later. We want to create an evaluation function. We've got mean squared log error. So how would we turn that into root mean squared log error? So let's try it out. So maybe we go here. I don't want to type out root mean, nah. That's too much. RMSLE. Root mean squared log error. Beautiful. And that can just take ytest and ypred. It's going to take the same inputs as my scikit-learn function. So see how this takes true, ypred. It could be ytrue, it could be ytest, doesn't really matter. Ytest, and then we go here. We'll leave a little doc string for ourselves. Calculates root mean squared log error between predictions and true labels. Wonderful. And then we might go return, just nice and simple. We can just use np square root of mean squared log error. We'll have to pass this to the test values and the predictions to mean squared log error. That's actually pretty easy. What we're doing here, we're taking the square root, so the root component of the mean squared log error, between predictions and true labels. Wonderful. So we've created our own evaluation function that lines up with Kaggle's requirements, the root mean squared log error. Okay, and we probably want to check a few more things, like we want to create an evaluation function to check a few things at the same time so we don't have to keep calling something like this. So let's create function to evaluate model on a few different levels. So again, evaluation is just as important as building the actual model. So we'll go here, show scores model. So we'll pass it our model. We'll make some predictions on the training data. So model.predict. So we'll evaluate how our model did on the training data, xtrain. And then we'll evaluate how our model did on the validation data, model.predict. We'll pass it our X validation here. If our model is performing better on the validation data set, that's hinting at us that our model is overfitting. So between training and validation, generally, because our validation set only has 12,000 examples and we're not training our model on it, you'd want to see slightly worse metrics on the validation set than versus the training set. So we'll go scores equal, maybe we'll return a dictionary of some sort. Yeah, so training, MAE, aka mean absolute error. We're gonna go, can I tab autocomplete mean absolute error? Yes, I can. Ytrain, so remember, we're just comparing the Ytrain, so this is the training mean absolute error on the training labels versus the training predictions. Beautiful. We're gonna go valid MAE. So again, you'd expect this valid MAE to be slightly worse than the training. This is gonna be yvalid, and this is gonna be valpreds. And then we're gonna go training RMSLE for root mean squared error, and we can do this using our fancy little function that we've just created up here. This is exciting. We're writing our own evaluation functions. Maybe that's a pull request potential to scikit-learn. Wonder why they haven't got root mean squared log error. Maybe it's not that popular, or maybe you can just easily create it yourself like that. Is that correct? Ytrain, train preds? I'm talking too much. Don't talk in code, kids. No, I'm kidding. You can do whatever you want. Here we go. Here, RMSLE, except don't under-evaluate your machine learning models. That's the only thing you're not allowed to do. Everyone loves a good model, but everyone loves a well-evaluated machine learning model even more. And finally, for good measure, since we're here, let's do the default score. Or maybe we just import that. That's probably a bit better. R2, is it R2 score? What is this? Why is this not working? Tab autocomplete is giving me some issues. So we got R2, oh, it's just, oh no, R2 score, yeah. Trust your instincts, Daniel, come on. R2 score. So that's all we're changing there. Rather than recomputing something, we'll just import it. Now this is a fairly decent function, I'm not gonna lie. Takes care of a few things. Train preds, probably some redundancy we could fix. but that's all right. We're trying to experiment as fast as possible. You might be thinking, wow, our experiments are getting slowed down. But with your own practice, without having to listen to me talk and go through these sort of things, you'll be whizzing through experiments. No, that's wrong, isn't it? This needs to be Valpreds. Valpreds. Beautiful. And we're going to return the scores. Okay, so what have we done here? So we've built an evaluation function in line with what's required for this particular project. And in our case, it's root mean squared log error. I'm going to go horse saying that if I keep doing it. And then we've created another little helper function that's going to do a whole bunch of other metrics. It's going to make some predictions using a model we pass it to. And then it's going to compare those predictions on a whole bunch of different playing fields, on the mean absolute error, on the root mean squared log error, and on the coefficient of determination. Whew! So that's probably enough for this one video, building our own custom evaluation functions. Now again, this is something you might want to do for your own projects. Because we're running as many experiments as possible, it is helpful to have evaluation functions like this so you can quickly do a whole bunch of different things rather than having to retype out this every time we try a new model. But let's press Shift and Enter on that so our functions are instantiated, and we're going to try and test them out in the next video.